Hello, AP Stats, Mr. Rivers here. I wanted to go over a couple problems from this example sheet that we didn't get to in class today. We made the dot plot to this problem, the soda can problem. We did that in class late last week. In class today, we did not talk about this problem. We'll talk about it momentarily. In class today, we did work the how many calories are in a slice of pizza. I want to talk about this one first, just to recap everything. When we're asked to describe a distribution, there's a few things we have to make sure we hit on: shape, center, outliers, and variability. So let me clear this out a little bit. First off, shape. The shape of this distribution, the shape of the distribution of the calories per serving for the 16 brands of frozen cheese pizza is roughly symmetric with peaks at 320 calories. You see that peak right there with 3 and 340 calories. You see that right there. If you wanted to say it's bimodal, that's okay. You could also say it's got peaks at those two places. You could say it has 2 peaks. That works. There appears to be a gap from 260 to 290 calories, 260 to 290. There's a smaller gap here between 290 and 310. You could say that if you wanted to. 360 to 380, there's also a smaller gap. You could say that too. Just any significant gap, right? This is kind of on the smaller side. If you listed it, that's totally fine, but I would say just make sure you have that large one between 260 and 290. Along with the gap, we need to have some context to this. That means we're talking about the 16 brands of frozen cheese pizza. Be specific, just look up top for that context. Also, we need to mention calories as well. So that has to show up along the way. Units are always very important when it comes to answering any AP stats problem. So there you go. The center, we're going to use the median for this distribution. Remember, we're just looking at the middle value. So here we have 16 brands. 16 divided by 2, we get 8. And so what we're going to do is we're going to look at the 8th and 9th element in this set. And you end up with 330 and 330. We need to find the mean of 330 and 330, which is, in fact, 330. So there we go. We're going to look at the median there. If we had an odd number, by the way, if we had like 15 values in this distribution, we would divide that by 2, which gives us 7.5. So we would look at the 8th element in the set. That would be the median value. So just want you to know how to like rapidly find the median without having to cross out the outer values and work your way inward. You're welcome to do that, but it's not a requirement. There's ways to do it mathematically. Outliers, there appears to be an outlier at 260 calories. You see that down there. We don't want to use definitive language. There's a way to definitively say that we have an outlier. We're going to learn that in section 1.3, but not right now. And then variability, the distribution of the data varies from 260 calories to 380 calories. Lean on that word varies when it comes to variability. Stay away from the word range. Range is a calculation. In this case, it would be the largest value, 380, minus the smallest value, 260. So this distribution has a range of 120. But for variability, and that is a measure of variability, but for the sake of this problem, we're going to say the distribution of the data varies from 260, the lowest value, to 380 calories. Make sure you include those units. There you go. Here we have a problem. I'm going to jump around a little bit. The dot plots below display 2 different sets of quantitative data. Graph A shows the results of 100 integers from a random digit generator. Graph B shows the number of grams of fiber in one serving of frozen cheese pizza for several different brands. Describe the shape of each distribution. So we don't have to use the shape, outliers, center, variability here. We're just asked for the shape. So as I look at A here, it's roughly symmetric. We have multiple peaks, which means we can call it roughly uniform. If you just said it had multiple peaks, that would be okay. There's no obvious gaps here. So when we kind of, put this into some nice, neat AP stats language, it looks like this. The shape of the distribution of the 100 randomly generated integers is roughly symmetric with multiple peaks, which makes it roughly uniform. There are no obvious gaps. We do want to use context here. The random number, or the 100 randomly generated integers, let's make sure we mention that when we describe the shape. Here in part B, This distribution has a longer tail there off to the right. This is skewed to the right. Unimodal with a peak at 2. You could say it has one peak at 2. Again, we're talking about grams of fiber, I believe, right? Grams of fiber in one serving of frozen cheese pizza for several different brands. So when we put this into a nice clean answer here, the shape of the distribution of the number of grams of fiber in one serving of frozen cheese pizza is skewed to the right. It is unimodal with a peak at 2 grams. There are no obvious gaps. Make sure you include context. What does the distribution represent? This one represents grams of fiber, number of grams of fiber in one serving of frozen pizza. Make sure you include units, grams. So yeah, got to be detailed in these answers here. How many metals? Making and interpreting stem plots. The table displays the total number of medals 28 countries won during the 2016 Summer Olympic Games in Rio de Janeiro. And let's just take a glance at this here. United States, there's 121 medals, China 70, Great Britain 67, on down to South Africa at 10. What's nice about this is it's already listed from greatest to least, which makes it easy for us to put it in the stem plot. So remember with the stem plot, we want to go with the smallest values on the top and then work our way down. So 1, 2, 3, 4. This is our stem. Remember the leaf is always the final digit. So if the final digit is going to be, let's see here. So with 10, 1, 0, that's 10. 11, 1, 1, that's 11. So our key here, 4, 2 represents 42 medals won by a country at the 2016 Rio de Janeiro Olympics. That's our key. We want to make sure we include context, which means medals won by a country at the 2016 Rio de Janeiro Olympics. Of course, you have to represent what the stem and the leaf is. So here you see the stem and leaf plot, pretty easy to do. Just start from the bottom, work your way up. 10, 10, 11, 11, 11, 11, 11. You see all the rest of them, they're there. A, make a stem plot of the data. We did that. B, describe the shape of the distribution. So to describe the shape, if you would tilt your head to the right, right? In other words, if we rotated this thing 90 degrees, it would look like this. And we got 1, 2, 3, 4. I'm not going to take the time to do it, but I will write out 1 here. 0, 1, 1, 1, 1, 1, and then 3, 3, 5, 5, 7, 8, 8, 8, 9, 9. And then for the group that is 20 to 29, 1. So you don't have to actually write these out, but I just wanted to draw a few so you can see what we're doing is we're taking this stem plot, we're rotating it 90 degrees counterclockwise, and you end up with kind of what looks like a dot plot a little bit. And from this, we can see, it's not a dot plot, by the way, but it kind of resembles one a bit. We can see that this is skewed to the right. We're going to get this long tail heading down here to the right, like this, all the way down to 121. So the shape of the distribution of the medals won at the 2016 Summer Olympics is skewed to the right. There is a single peak at the 10 to 19 interval. There is a gap from 70 to 121. We were asked if there's any obvious outliers. And I said 121 appears to be an outlier. So let's make sure we are using context when we answer this, talking about the 2016 Summer Olympics and the medals that are won. Let's make sure we're talking about whether it's skewed to the left, skewed to the right, or roughly symmetric. Sometimes it is roughly uniform. The word roughly can really help us out. This is clearly skewed to the right, so we don't need to throw the word roughly in there, but if it's ever close between maybe symmetric and skewed to the left or the right, the word roughly can kind of do some heavy lifting for us when we're kind of on the fence between the two. Let's make sure we include that single peak. If you wanted to call it unimodal, that's okay. And then the outlier as well. So there you go. That is the stem plot for the Rio de Janeiro medals. Okay, here is the pair of shoes problem. How many pairs of shoes does a typical teenager own? To find out, a group of statistics students surveyed separate random samples of 20 female students and 20 male students from their large high school. Here are the dot plots of the number of pairs of shoes owned by the survey respondents. Compare the distributions of number of pairs of shoes for females and males. So in a comparison, we need to state what is higher, what is lower. We need to use language that is like directly comparing the two. That's really important in AP stats. So again, we're going to use shape, outliers, center, and variability. So I'm going to pause the video and write these out here. Okay, what to write here for the shape. The shape of the distribution of the number of shoes owned by the 20 high school students surveyed is roughly symmetric for female students and skewed to the right for male students. The female sample has a single peak at about 12 shoes. You can see that right about there. And the male sample has two peaks at about 10 right there and about 7. The female sample has a gap between 39 and 48 shoes. I'm going to throw in pairs of shoes. The male group has gaps between 13 and 21 shoes and 21 and 35 shoes. So we've talked about the shape, we've talked about the peaks, we've talked about the gaps. If you said the female sample is roughly skewed to the right, the male group is clearly skewed to the right. But the female group, we got these outliers out here that creates that long tail off to the right. So if you said it's roughly skewed to the right, I would take that. It's kind of on the fence between roughly skewed to the right and roughly symmetric. I like either of them, but that long tail is kind of the dead giveaway. No one's going to give you a hard time because of that long tail going out there, right? It's rough. I mean, I don't know. Maybe skewed to the right's a better. Yeah, I'm gonna change that to skewed to the right. I like skewed to the right better than roughly symmetric, so I'm gonna say roughly skewed to the right. It's kind of close though, right? Roughly skewed to the right. All right, so sorry for the poor handwriting. Let's now talk about outliers and center and then variability. The female sample appears to have outliers around 50 and 58. So there's 4 clumped around 50. If you wanted to say there's 4 around 50 and 1 at 58, that'd be great. Love that. The male sample appears to have outliers at 36 and 39. If you're in the ballpark of these, that's okay. Outliers are kind of a giveaway for if it's going to be skewed to the left or to the right. So just kind of keep that in mind. If you look at a distribution and you think, yeah, there's definitely outliers there, odds are it's skewed to the left or to the right. So that's part of the reason I went and changed that from symmetric to skewed. I started thinking about the outliers and I thought, if we got outliers, I probably should say it's skewed to one side or the other. Let's talk now about center. So remember, if we have 20 elements in the set, we're going to divide that by 2, which gives us 10. So our median is going to be the mean of the 10th and the 11th element in the set. So let's just go ahead and count here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 is these two. So for the females, I would say the center is roughly, looks like about 26. For the males, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me do that one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11th element in the set is 10. Looks like the 10th element in the set is 9. So about 9.5 for the median there. We don't have these exact values. If we did have them in the table, we would need to find the exact median, but I would probably take a median of 10 or 9.5. I like 9.5 better, but because we don't know these exact values, I think I like either one okay. Here's what I said. The median for the female sample, about 26 pairs of shoes, is higher than the male sample, about 9.5 pairs of shoes. So what do we need here? We need to compare the two. We need to say one is higher than the other, or if they were about equal, you would say they're about the same. But we are asked to compare the distributions, which means we need to use that comparative language. One is higher than the other. And let's also list what those centers are as well. So that about symbol is not necessary. If you said it's 26 pair of the shoes, like, yeah, I would take that. But remember, we want to provide, we don't want to speak in absolutes. We want to provide like kind of like more general statements whenever possible. So about, roughly, these are good words to use like when it's not exactly known. Variability here, the number of pairs of shoes for female students varies more from 13 to 57 pairs than the males from 4 to 38 pairs. So when it comes to variability, let's make sure, again, we are comparing the two. So we have to use comparative language, meaning we are saying that the number of pairs of shoes for females varies more, like it's a larger span here from 13 to 57 than the males from 4 to 38. So be careful with that wording. We've talked about staying away from the word ranges, because range is a statistical term where it would be 57 minus 13. So the range here is 44. The range for the males is 34. So when we're talking about variability and we use the word varies, let's make sure we don't sprinkle the word range in there or ranges. Just be careful with that. Let's make sure a few things too. We're including our context here. Number of pairs of shoes for female students. We're talking about like what the sample represents. We're talking about female students. We are talking about male students in this as well. We're talking about pairs of shoes. So let's make sure we're using language that represents what this distribution is, what it represents. That is something that you are graded on both in this course, but also on the AP exam. So prepare accordingly. Thanks for watching.